Okay. One of the most important parts of any of our projects, it doesn't matter what we talk about in emails or meetings or other correspondence, but the main part of all our projects is the model reviews. It's where the client, he'll agree with our changes, or he'll make changes, or he'll make certain requests. We have stage 1, 2, and 3 model reviews. Basically, stage 1 is we'll probably, it'll set prior, but usually stage 1 is about 30% of a project stage. Stage 2 is approximately about 60% of a project stage. I'll tell you what these stages are in a minute. And stage 3 is basically the 90% of a project stage. I'm looking at page 116 in your handout. Setting up the model review takes a lot of coordination. There's a lot of people who have to get involved from all disciplines: piping, structural, electrical, instrumentation, utilities. We're looking at the design coordinators for each unit, system coordinators, lead discipline designers, engineers, project engineering manager, and also the customer has to get involved in all these reviews. Usually the requirements are set up well in advance of getting to the stage 1. Basically the schedule of the model reviews has to be set up and approved. Also the contents of each model will have to be approved. Prepare for a model review. We'd have to develop agendas for these model reviews. Somebody will be responsible for setting up the people. Usually from a Worley Parsons point of view it's not so problematic, but we have to have operators, client operators, maintenance, safety personnel. We'll have inspectors, QA people. The room could be full of 20, 30 people. And basically Parsons support for all this. There's a lot of people looking at the design and making comments. It's important that from a company point of view that we're well prepared in advance for all these model reviews. We'll have somebody conducting the review, usually the project lead, project manager. He'll assign somebody who's going to take notes. We do actually tag the model. I'll show you that in a minute, how we actually record all the comments from the client. And basically when we do that we also have to take the we'll take an action tracking list, which again I'll show you when I get into the smart plan review, and that'll basically show when we make a comment that whose action it is to actually follow through with that and proceed to a resolution. Going to page 117.
So when you review the model, you just you check with PFD or PNID or just see the model?
Each client has his own preference, and that'll be set up prior to it. Most clients will have his own set of documents in front of him, which may be a P&ID. But one client we had, he wanted to do a P&ID yellow off. He wanted to go through every component and review every component. He felt comfortable doing it that way. This is something that the client and our project will set up prior to the meeting. The difference between doing a yellow off takes days, and prior to just reviewing it, it can just take an afternoon. Depends on the size of the unit and the extent of the requirements. But some of our clients do go into this in very deep detail. At the 30% of a project, the sort of thing that we would normally expect to have ready is that the P&IDs would be issued for a HAZOP. That'll be the stage of them. Line lists, equipment lists will also be issued for HAZOP review. Equipment location plans will be issued for design, which means we would have issued from approval, got feedback from the client, they'll be in issued for design stage. Modelling of major equipment All major equipment will be modelled, not minor equipment, just major equipment. It'll be set up prior to the meeting what we consider major and what we consider minor. It may be some of the smaller pumps, some of the major pumps will be required. Certainly other vessels and drums, exchangers will be required to be modelled. Some of the minor equipment will be required to be modelled. Usually before the meeting there'll be a list of what's complete and what's not complete, and that'll be issued to a client for his review. 8-inch piping will be modelled. Sometimes we will show a lot more than just for 8-inch piping and larger. To me, as far as our requirements, the more we can get at the 30% stage, the earlier the client can see it, the better it is. As soon as we get his feedback, the better. But all our requirement is at the 30% stage of the model. It's just to have 8-inch and larger piping available for him to review. Primary steel, all modelled, and it will be frozen after review. Primary steel, you're probably just looking at your pipe racks, your elevations. You're probably not looking at the structures outside the pipe racks. Stair towers want to be modelled, first pass by piping for a layout review. Monorails, they want those to be modelled at the first stage of a pass. So a lot of the information at the 30% is just very preliminary information. We still don't have some vendor information, and things can change. Going to page 118. Going to page 121. Page 121 basically lists the what's required at stage 2. Say at stage 1 we had IFD P&IDs. Now we're looking at the 60%. We've got to have IFC P&IDs. And usually when we have each stage of a P&IDs, obviously it's in the client's hand and he's had his chance to look at it and review it and make comments as well. Line list needs to be at a Rev 1 IFC status for 60% model review. Equipment list is IFC, issue for construction. Equipment location plans have to be issued for construction. And also, one of the first things, when we get to the 60% review, one of the first things we have to go through any comments that the client made at 30%. We have to look at those and tell him what our resolution is or why we didn't resolve the issue. At each stage there will be client comments. Vessel internals, final supplier data, all nozzles orientated and frozen based on vessel data sheets and also their sub-vendors' internal requirements. Modelling of major equipment, all modelled. Major equipment fully checked to code C1 supplier data, final certified. Modelling of minor equipment, all has to be modelled at 60%. And that is usually just a preliminary vendor data. 8-inch and above piping will be a final design. 8-inch piping supports needs to be all modelled. This is part of our stress requirement as well. All this will be in stress and feedback from stress on to make sure we don't overload any of the equipment nozzles. Structural supports for 8-inch and above piping, all modelled. Engineering to include structural model and include monorails and other mechanical handling, all modelled. Material handling reports IFC. That's begun at the 60% stage. Primary steel has to be issued for construction. Modelling complete. The secondary steel has to be all modelled and ready for IFC. And the secondary steel could be structures supporting exchanges or even just T-posts and that type of steel. Framing details, all modelled. The supports for all major equipment has to be modelled, engineered and modelled by the structural group. Pipe racks, IFC and modelling complete. Platforms have to be, access platforms all have to be modelled and reviewed. And that's what our requirements will be at the 60% review.
Okay.
Yeah?
What's the hell is
Oh no, just this. It's something that came out of our London office.
Oh, okay.
It's not a requirement. We don't do offshore. There you go. There's your clue right there. Yeah, this covers offshore as well. That's why I've got gaps on jumping. Going to page 126. When we get to the stage 3, which is usually 90% of a project, first thing we'll do is we'll go through all the previous comments for 60% made by the client. We'll review the see if we're accepting the comments to see how we fix them. What we can do is when we show a model review, we can show them the old model. We freeze old models after the review. We can show them the old model, we can show them a new one, and we can show them the change quickly that way, and see if he'll accept and sign off the model comment. PNIDs may be at the Rev 2 IFC stage. Line lists may be at the Rev 2 IFC stage at 90% of a project. Equipment list should be Rev 3 IFC issued. Equipment modeling should all be frozen. All equipment should be fully checked and certified. 8 inches above piping, IFC frozen, probably in fabrication at this stage with the vendors. All supports final design, line by line review, outstanding lines. Structural supports for 8 inches above piping should be frozen at this stage, issued for construction. Monorails and other mechanical handling equipment should all be in their final design stage, ready to go at IFC. Piping interfaces, tie-ins with other units, that should all be frozen. Main ladders and supports, platforming should all be frozen at this stage. And at this stage we should also have a lot of the work from our instrumentation electrical group, our junction boxes, our lighting fixtures, HVAC units should all be incorporated at this latter stage.
And if your bulk piping is only 90%, what's left to do at this stage?
It may be some utility piping. It'll all be small bore. It may be some airlines, and maybe some to equipment. Maybe some oil mist. It'll just be small bore utility type piping. 131. It basically gives the sort of considerations that we go through during the model reviews. So you have to understand this room is usually full of people who've been operating and maintaining and safety of the plants, and they've been doing this for the last 20, 30 years. We tend to send their project leads, their managers down to these reviews. We have to consider the safety hazards we'll look at during the review. Temporary access platforms, guarding, handrails, access ways. Equipment, we'll look at crane accesses. Lifting, we may want some lifting studies for getting the equipment in place, or some pre-assembly for some of the equipment. They're looking at may require some rigging studies to be considered during the review. During the steel, we'll look at crane access for putting the pipe rack together. So they'll look at the scaffolding obstructions for doing their work. Piping, they'll consider the erection techniques. Again, it's rigging. They'll look at some of the liftings for some of the major lifts. They may consider some of the hydrotest vents and low point drain locations. Electrical will look at the erection techniques and sequencing, and the arrangements and the locations of the cable trays and ladders, particularly to some of the major pumps and stuff. A lot of times we just show the cable trays, but don't show the cable itself, so they may require some additional backup paper for that. And these are sort of checklists that we'll go through during the model review. Now what it shows on page 134, if a client makes a comment, we have to tag the model. I'll show you a tag in a minute. But anytime he'll look at something, He may not agree with what we did in our design, or he may just want to make a change, or he may even want to increase the scope of work. But we'll tag it, and that'll become a topic of discussion later. So we'll just have to, these items will be put into the model, and I'll show you how it reviews in a minute. But he'll be tagged with whoever made it, with his name, the date, what his concern was, discipline to action, whether it's on piping, structural, electrical. So that will give somebody a focal point to fix it. It's the same as a resolved by, a date has to be resolved by. And usually that date has to be before the next review. So the 30% comments have to be resolved before the 60%, 60% comments have to be resolved before the 90%, etc. The lead discipline design engineer is responsible for timely resolution of the tags and smart plant review. All tags must be cleared before the area can be issued IFC. Okay. What I'm going to show you, this is the amine plant we did for CNRL. So I'm going to show you the smart plan review for this location. I'll just show you some of the design considerations, what the client looks at, and what sort of comments he makes at. What I want to show you is this is a snapshot. So, what you have to understand is that when you build physically in real life, we do exactly the same thing in the smart plant. Everything is full size. It's just for the graphics we obviously shrink it, but everything is built to the actual whatever the flange is, or the pipe is, or the equipment is. Everything is built to one-to-one scale. This is what's in the model. That's how it looks in real life. It should be identical to the bolts, flange, the pipe. You can see. Right, so you can see the three vessels we have here. We have a line coming up to the top right there. I keep going the wrong way. You see, this is a module structure we built it into right here. You can see the hand railing in yellow right here, but it should be the same, one-to-one. This is just showing one of our upper platforms, control manifolds over here. You see the tall tower. This is how it looks in real life. This is the manifolding. This is the tall tower, the platforming. It's all the same. Yeah, obviously we've not installed this piping at the moment, but you can see here it's what you see in the model is what you see in the field. This is showing a couple of stacked exchanges here, a little manifolding on the top there, some cooling piping. You see the manifolding the same, stacked exchanges, you see the steel framing. But what you see in the smart plan is what you'll see in real life. And that's what we review. Here we've got a little structure supporting some overhead lines, some shell and tube exchanges. You can see the offset piping, some breakout flanges, I think the stairways are being, yeah. It's the same thing. This is the structure, this is the pull area. These lines have been insulated. We've got breakout flanges right here. But what you see, it is as close as you can get to really doing the fabrication, construction. Okay. Okay. This is an amine plant that we did for the CNRL project, and it's has a lot of basic equipment in it, but it has a good varied equipment. I mean, a lot of the things a client will look at initially. This model's at 90%. That's where it's taken from. So we've already had a lot of comments and resolved a lot of comments. But you can see he'll look at the equipment. We model the roads in here. You can see here we have a tank. We have a containment wall around the tank. I'll go and zoom. I can look at a fly on a piece of pipe. It can go in that close, you know. But you can see we're showing the access to a tank because it's basically an oily tank. We just take out the oil in here and truck it away. You can see the access roads here. You can see the equipment backing off onto the equipment. You'll see some manways on this side here. The client will probably start it just by doing a quick overview of a project. You know, so.
Is the learning curve pretty steep on this program?
Takes a while.
Yeah, like years.
No, not at all. I learned it in 10 minutes. I don't know. But it's you know, it's but they'll zoom in. They'll just look at an overview. They can look at it from any angle. I mean, I can go from the top here. I can create plan views. You know, it's the biggest problem we always have in these reviews is we have so many people and everybody wants to talk at once, but there's only one person driving this machine, and it's and it can be cumbersome. You know, he'll look at it from a plan view. He'll look at the buildings. You can see here we got some. You know, we got some pumps. You can look at the maintenance backing onto the road. Here we got build. I'll show you inside the building in a minute, but we do have some filters and other maintenance equipment inside here. So he'll look at access to all this equipment.
So you can tag right on the program?
Yeah, I'll show you how we do that in a minute. But he'll just start by doing an overview for the equipment positioning. So this is just one model. We had about 7 or 8 models for different plants and different units. He'll look at the access to these manways. He'll look at the stairs coming off. He'll look at egress from this to the pipe racks. We have another unit over here, but you just can't see it because I don't reference it in, and that's why a lot of this piping is here. You can see here in red, this is our underground fire hydrant. These are positions. You can see here, this is a fire hydrant right here. I can zoom in a little bit closer later. But this is actually a fire hydrant which we show to monitor if there's a fire in this location right here. There's actually some over here which I don't show for some reason. But in this case we do have a fire hydrant. And what you can see here is actually some of the underground piping. We do actually, we detail everything including the underground. So you can see here, this is, you can see some of the piling here. You can see some of the underground piping. You know, so I can go in a little bit closer. You know, you can see it's. No, I should just show you. This is showing an underground tank, an underground sump right here. This is showing the drain piping going to this underground sump location right here. But whilst we're driving around this, then what we'll tend to do is we'll tend to look at a piece of equipment like this, in this case a flash drum. And what we have down here is we have a text box right here. Everything is intelligent inside the model. Let's see if I can, oh here, So if I snap on this vessel here, it tells them the equipment nozzle 50C3 here, tells them it's a rich amine flash drum. So it gives them the information that he knows right here. If I go into a pipe right here, I think I may have to scroll down a little bit here. But when we snap to the piping components, it'll give him the line number. It'll show him, in this case, it's a 60-inch pipe. WF, we know it's a flare system. Tells them that it's heat trace. It shows that it's got electrical tracing on it. There's no painting requirement. It shows that we have W-type insulation, which is well, I can't remember what the type is. He'll get us to
How are these information inputted into the
PDS. Everything is done by PDS. Bob Carboni is going to run your class on PDS. Now you have piping PDS, you have structural PDS, you have electrical PDS, you have instrumentation PDS. And maybe I can show you right here. Let me see. What I can do is I can let's see if I can do this. If I can switch electrical off.
Essentially, this information has to be inputted.
Oh yes, it's all done big. This is Smart Plant Review. This takes all the PDS files and makes it into one review format. So PDS is where we build it. That's where we extract our drawings from and where we send them for fabrication. And that's where all the intelligence comes from. So we just reference all those PDS files into this file right here where it is reviewed. We get our checkers to review the design on this. We coordinate within our disciplines using the Smart Plant Review. And so I think a client will look at here is he'll look at the manway. He'll look at this ladder coming up. We can dimension anything on here as well. For example, he wants to know the length of that drum there. Just let me find it.
Can you give us a rough order of magnitude of hours that went into making this?
Hell no. I do know what it is for a piping group. Piping group, not for this, but you got to understand there's about 8 units. This project was 131,000 piping man hours for this project. So what is? But on this, I can snap to dimensions. I can click that component. I can go to say another component to send over here. And that will tell him right there. And that will tell him that from end to end, he knows north is up, that this drum is 28 meters and 41 millimeters long. This is a metric project, by the way. So he can see right here. If he wanted to say, look at one of the manways. If you want to know how much access he had, say, in one of the manways, and we can just go there, snap to this, and I can just show him from here. That's not the right one. I can always maybe give him a dimension from here, this flange, to say this end of that platform here. I know it's in the east. So it tells them that it's 1.1 meter from that flange. This box, this dimension box, is from that point to that point, and it's telling me that from that point to that point, in north in this case is up. I am 1.18 meters. In the east, I am 1.1 meters. Elevation is different. It's 1.16 meters in difference in elevation. So you can tell me that man weighs just 1.6 to the center line above that platform, and he'll know the criteria and the requirements, and he'll just ask us to verify that and make sure it's acceptable. He'll look at the let's do that. Let's get it right. He'll look at the egress. Yeah, he'll look at the going up this platform. He'll look at all the equipment that we have in this area here, and you can see the requirements as to. If I put structure on, it might help. Just give me a second here. Just give me a second here. I've switched off the pipe rack for some reason. There you go. Nobody noticed there's no steel there? But they'll look at the We'll look at access. This is a platform which is going up away from there. So we'll look at egress to these platforms, make sure we comply with the codes and requirements. Other things that we can do is, let me see if I can find this for you. Here, look at some of the piping control valves, manifolds. Let's see if I can get this for you. There's control F3. I can move him. Tin man. Move. Pick a point. I can put a man right there. We have this man called a Tin Man. He's 6 feet tall.